Well, in this video, we're going to talk about verifying our identities, or verifying an equation is an identity. So this first example right here, I want to verify that the left-hand side equals the right, or vice versa. We've been talking so far, or learning, that when we do these types of things, let's try to take the more complicated side and turn it into the easier side. So the left-hand side looks more complicated. I'm going to see if I can rewrite the left-hand side so that it looks like the right. When I'm looking at the left-hand side over here, right away I see this first term looks like the sum identity for sine that we just talked about. So I'm going to rewrite it using that identity, which says it's the sine of the first times the cosine of the second plus the cosine of the first times the sine of the second. Now the second term here is again the difference identity for sine, so let's rewrite it using the sine of the first cosine of the second minus cosine of the first sine of the second. So what I have here are 4 terms, and I'm going to see if I can combine any of these like terms. Starting here, I have a sine x cosine y. I have another sine x cosine y. So I have a total of 2 sine x cosine y, so they're gone. Now I have a cosine x sine y minus cosine x sine y, so that's gone. All this leaves me is 2 sine x cosine y, which is what I wanted to try and turn it into, and sure enough I did. So that one's done. Alright, not bad. Let's look at another example then. This identity says the cosine of alpha minus beta over the cosine of alpha sine beta. And I'm saying that that's equal to the tangent of alpha times the cotangent of beta. So again, in this particular case, the left-hand side is actually more complicated. Let's see if we can rewrite this in terms of the right-hand side over here. So right away I notice that the numerator has something that I can apply the cosine identity, the difference identity for cosine of. So I'm going to rewrite the numerator so that it looks like the cosine of alpha times the cosine of beta. Remember, that's what the difference identity for cosine is, plus the sine of alpha times the sine of beta. And all of that's over this common denominator, or this single denominator, cosine alpha sine beta. Well, the next thing I probably want to do is I want to break this up as 2 separate fractions. Notice that I'm adding my numerator here, so I can rewrite this so that it looks like the cosine of alpha cosine of beta over this denominator, cosine alpha sine beta, plus sine alpha sine beta over that same denominator, cosine alpha sine beta. Well, now that I have it written as 2 separate fractions, notice that this fraction right here is all in what I would call factored terms. Something times something and something times something. In other words, that allows me to cancel or get rid of common terms. So this cosine and this cosine of alphas cancel or reduce. And I can apply that same concept over here where those are similar, so I can cancel them. And that leaves me with just cosine of beta over sine beta plus sine alpha cosine alpha. In other words, I have cosine and sine with the same angle measurement. And over here I have sine and cosine with the same angle measurement. Well, I can rewrite cosine over sine as the cotangent of beta, and this one is going to be tangent of alpha. Well, tangent of alpha, cotangent of beta. Tangent of alpha, cotangent of beta. Same thing, right? Okay, so that was how we showed that that was truly an identity, or verified that identity. Let's look at one last example together. This example right here says the sine of x plus y over the cosine of x minus y equals the cotangent of all of this stuff over here on the right. So let's see how we can verify this identity. Remember, we're trying to determine which of these two sides is more complicated. It turns out that the right-hand side in this particular case is more complicated. If I were to use my sum identity for sine and I expanded this out, that creates a rather complex looking problem. So in other words, this is actually simple compared to the right-hand side over here. So having determined I'm going to start on the right, and I'm trying to take cotangents and rewrite everything in terms of sine and cosine, then let's use that idea. So everywhere I've got a cotangent, I'm going to rewrite it as sine and cosine. So this term is going to be the cosine of x over the sine of y plus the cosine of y over the sine of x. In the denominator, I have 1 plus the cosine of x sine of x times cosine of y sine of y. So it looks more complicated, but we're going to do something to make it not quite so ugly. Remember, in a previous video here on this same section, we talked about a complex fraction like this and how we got rid of the denominator. Notice here I have a sine, and then I have sine x, sine y in the denominator. Now this is sine y and this is sine x, but at least they're all in the same function, right? They're all sines. So let me go back up here and show you what we did using actual numbers. Okay, it's over here. So remember when we had this complicated thing and we found or we used a single common denominator to all of these denominators, which was 3, and I multiplied both the top and the bottom by that common denominator to get rid of it. Well, we're going to use that same property down here. So let me go back to where we were. Now, sine y, sine x, sine y. That's what we have right here. So my least common denominator of all 3 of these things is going to be sine x, sine y, because it's just a combination of it. So if I were to multiply the top by sine x, sine y, and the bottom by the same thing, then I'm technically multiplying by 1. So let's just handle the numerators. Let's see what's going to happen here. Again, I'm going to take this first term and I'm going to pull it out and I'm going to show you what it is that we're doing. So we have cosine x, sine y, and we're saying I want to multiply that by sine x, sine y over 1. Well, what happens? What cancels here, right? The sine y's cancel, leaving me with just cosine x, sine x. Cosine x, sine x. So I took something that had a fraction and rewrote it like this. I got rid of that denominator. We're going to do the same thing for this term right here. Well, what do you notice happened here? In the first term, the sine y was the part that canceled. So if that's what cancels in the second term, only it's the sine x, okay, my sine x's will end up canceling, then I'm going to end up with cosine y, sine y. So let's rewrite that. Plus cosine y, sine y. So in the denominator, we're going to do that same concept, and we're going to multiply this to each of these two terms. So when I multiply sine x sine y times 1, I get sine x sine y. Now watch what's going to happen when I multiply sine x sine y times this whole thing here. Sine x and sine y in the denominator here that I have highlighted in green will cancel with these sine x sine y's, and all that leaves me is cosine x cosine y. That's pretty complicated, so make sure that you understand what it is that I'm doing, and you can go back in and you know, step by step, if I lose you, try to see where it is I actually lost you. Okay, so what I've done is taken this rather complex fraction and turned it into this statement right here. Now, what do you notice about this? I have the cosine and the sine of the same angle plus the cosine and sine of a different angle. Well, that's our new identity that we just learned today. That would be the sine, the sum identity for sine, x plus y. And I'm hoping, because remember I'm trying to turn this into the difference identity for cosine, and sure enough, that's what it is. It's the cosine of the first times the cosine of the second plus the sine of the first times the sine of the second. So it's written backwards, but it is the same thing. So this is the cosine of x minus y, which is what we tried to turn it into. So this is a really, really hard problem in this step, but once you get past that step, I don't know, it just kind of falls in place. Okay, so if you have a hard time understanding this step here, go back to the example we worked way up here in this lesson from 5.4a, and this was what? Example 2b. And that problem right there shows you using numbers, right, instead of trig functions, what it was that I just did in that identity. Okay, that's it for that video.